Hi, hello everyone. Very good evening, one and all. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep. Warm welcome to the session. Join the session quickly and mark your presence. Sagar, good evening. Ashwani, good evening. Everybody, join the session quickly. Mark your presence. Kaustub, hello. Hi, Shruti. Everybody else, quickly join. Today, we will practice the subject operating systems. Before we start, let me introduce myself quickly. I am Satya, research scholar with 15 plus years of teaching experience. I have mentored more than 35,000 students in the GATE and PSU categories. I am qualified in GATE, UGC NET, SET and certified by Cisco into networking and programming. My areas of expertise include programming data structures, algorithms, computer networks, computer organization and architecture, and operating systems. Guys, our favorite Abhinav Negi sir, who has pursued his MTech from IIT Delhi, will be taking a mega workshop for 2024 GATE aspirants, where he will share 7 success mantras to become a beginner, a topper. How a beginner can become a topper. Regarding that, 7 success mantras will be shared by Abhinav Negi sir on 15th January at 12:30 p.m. So, please inform your juniors or your student, your friends, whoever are aspiring for 2024 GATE, so that they will benefit out of it. Hi Satya, Kalyan, good evening. Aryan, good evening. Okay. Now you can avail 90% scholarship, guys. Already the scholarship test happened at 12 p.m. So if you have not attended, please go through it. If it is still live, you can take it today. Okay. Now for your GATE preparation, test series is available from our BYJU'S Exam Prep site, which will offer you 4,000 plus practice questions that include 40 plus full length mock tests and 30 plus subject wise tests, also part tests. And our tool will provide virtual calculator so that you get a feel of writing the real GATE exam, and complete detailed mock analysis will be given so that you can assess yourself where you stand in the All India level competition. Okay, so avail this test series, make your preparation strong. So guys, from operating systems, the official syllabus is what we have is this: processes and threads, CPU scheduling, deadlocks, IPC synchronization, memory management, virtual memory page replacement algorithms, page tables, disk scheduling, file systems, and system calls. This is what the official syllabus we have for operating systems, isn't it? Everybody, could you please confirm my visibility and audibility? Dear friends, am I visible and audible? Please confirm in the chat box. Am I visible and audible? All right, all good. Superb. So guys, please do share this session information in your student groups wherever you are connected so that everybody join the live session. Okay. So in today's part 1 marathon of operating systems, we will be practicing majorly these 4 topics: process states, threads, CPU scheduling, disk scheduling. So in the tomorrow's marathon, we will practice the rest of the topics: deadlock, synchronization, paging, okay, file systems concepts. So are we good to go, everybody? Please type go. Shruti, yes, but live experience would be different. So prefer to attend live classes. Okay, chalo. Let us start our operating systems marathon part 1 with the topic processes and threads. Before that, please do follow the guidelines to attend this marathon. You will be given total 45 questions today, and every question has either 60 seconds or 120 seconds of time based on the difficulty of the question. And as and when I display the question, the timer starts. And please attach the question number when you are giving your answer and try to solve on the notebook, not in the air, so that accuracy would be more. And please do maintain the comment log to understand your mistakes. Okay, chalo, let us start with processes and threads topic. Assess yourself how strong you are in this topic. Okay, first question on your screen. Suppose the size of ready queue is full, also CPU is busy. If a high priority process is created at this instance, then which transitions should take place in order for the new process to be loaded into main memory? You have the options in front of you. Quickly give your answer with the question number attached. New to ready, ready to running, ready to suspend, new to ready, new to ready, ready to suspend, block to suspend, new to ready. Quick. You have 10 seconds left. 5, 4, 3, 2, 1. Time up. What's your answer, dear friends? Option A. Prajwal is giving option A. Okay. What about others? Hi Ashwati, good evening. Welcome to the session. Kalyan option B. Shruti B. Suraj B. Tirumalai A. Aryan B. Satya B. Okay. Okay. Everybody, try to make the session interactive, please. Please give your answers in the chat box. If you keep giving the answers, it would be more interesting. Okay, let's see the process state diagram once. We have new state, ready state, running state, exit state, blocked or waiting state. These are the regular phases in any process life cycle. But we do have two special phases. They are suspend ready and suspend blocked. Right? These are the 7 phases. Now, when the ready queue is full and CPU is also busy, there is some process already in the CPU in the running state, right? So which transitions takes place? For a new process to be loaded in the main memory. If a new process to be loaded in the main memory, that means it should be in the ready state. But ready queue is full. So first a process should be suspended from the ready state. Then a new process can be admitted from new state to ready state, means loaded in the main memory. Right? So ready to suspend, new to ready. Right? So this is what the transition that has to take place. So the answer is ready to suspend, new to ready. Option B is the right answer. Clear? Chalo. Next question. Consider 3 processes currently in ready state, suspend state, blocked states respectively. Their memory locations are respectively in dash order. Give your answer in the chat box with question number, please. Quick. 15 seconds left. Five seconds left. 4, 3, 2, 1. Time up. Time up. What would be your answer? When a process is in the ready state, what is the memory location? Suspend state, what is the location? Blocked state, what is the location? When the process is in the ready state, undoubtedly it is main memory, right? Undoubtedly it is main memory. So definitely it is not option C. And when the process is in the suspend state, undoubtedly it is secondary memory. So 2 options filtered out. When the process is in the blocked state, means waiting state, will it be thrown out of the RAM? No. The process is still in the main memory only. So the right answer is option D. Okay, Ashwati, Rajat Yadav, hi Nishu, clear? Chal. Let's proceed to question number 3. If the IO action for a suspended process occurred, then such process transition would be suspend wait to ready, suspend wait to running, suspend wait to suspend ready, suspend ready to ready. If the IO action for a suspended process occurred, then such process transition would be. 20 seconds left. Use the question number for giving the answer. Ten seconds left. 5, 4, 3, 2, time up. Yep. C, A, B, B. Yep. If the IO action for a suspended process occurred, then such process transition would be. Here the question need to be more clear. If waiting queue is full, then we can say, how many of you are with this comment? Sir, the question should be more clear, sir. You did not mention whether the waiting queue is full or not. Then only we can say properly. How many of you say that, sir, this is what required, this information is also required? Are there anybody who says that this information is also required? Anybody? Okay, great. That means you are good at. Not needed, guys. That information not needed, because whenever the IO action occurred means whenever IO action occurred, for which IO action the process is waiting for, that IO action occurred means it is ready. It is no more a waiting process. It is no more a waiting process. So it doesn't matter whether the waiting queue has a space for it or not, because it is not a waiting process. It is not supposed to be in the waiting state, right? So it is suspended due to the unavailability of space in the waiting queue. Then only it is suspended, right? Even after suspended, if the waiting queue become vacant also, it is not supposed to go to the waiting state, because now it became ready. So it will go from suspend wait to suspend ready. It is not supposed to be in the waiting state at all. Not required, Nishu, Shruti, Rajat Yadav. It doesn't matter whether the waiting queue is full or vacant. Is this point clear? It is no more a waiting process. Is the point clear? Everybody? So guys, please update your scorecard accordingly. Chalo. Let's proceed to question number 4 on your screen. Which of the following sequence of system calls is or probable for a particular process in process life cycle for a uniprocessor system? It's a MSQ question. You are given 2 minutes of time for this. 2 minutes of time. Because you should go through every sequence, I have given 2 minutes time for this. Last 1 minute. Twenty seconds left. Okay. Time up. A and C options are same. Okay, it's my bad. Right. A and C options are, yes, they are same. Okay, I'll give 1 more minute time. I'll give 1 more minute time. Please, now you give your answer. Okay, I am giving 1 more minute time. Now you give your answer, guys. Twenty seconds left. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time up. Yes, everybody, I want your answer now. Okay. Fine. A, B, D. I think A, B, D, A, D. All are giving these answers. Fine. Let us see. First, dispatch, preempt, suspend, resume. Dispatch means ready to running. Preempt, running to ready. Suspend, ready to suspend ready. Resume, suspend ready to ready. Possible? Possible sequence. Option B, dispatch. Dispatch means ready to running. Preempt, running to ready. Dispatch, again ready to running. Block, running to blocked state. Yes, process can go. Suspend, blocked to suspend block. So it is also possible. Now option C. For option C, let me hide myself just for a while. Suspend. To understand suspend, it may be from ready to suspend ready, or blocked to suspend blocked. It can be any transition. We don't know. So if a process is suspended, then can it be dispatched? From suspended ready to dispatch means ready state, not ready state, running state. Is it possible? From suspend ready to running state, is it possible? No. Suspend blocked to ready running state? No. So you assume any, it is not possible. It should be resumed first, then it can be dispatched. So definitely option C not probable. And option D, if you look at suspend, resume, dispatch. So from this sequence you can understand the sequence is a process is suspended from ready to suspend ready, then suspend ready to ready, resume. This is suspend, this is resume. Dispatch, ready state to running state, running state to ready state, preempt, again dispatch. Yes, possible. So A, B, D are probable, but C is not probable, right? Hence the answer must be A, B, D. Shruti, Kaustubh, got it? Ashwati, Aryan, Satya, I think you all got it. Okay. Question number 5. Consider the following statements about process state transitions for a system using preemptive scheduling. Which of the below statements are true? Nishu, 45 questions, let us try to solve. Okay, based on the time. Hi Aarti Seeman, I am good. How are you? Guys, keep inviting your friends for the session. Ask them to join live. Quick, give your answer for the question number 5, everybody. 10 seconds left. 5, 4, 3, 2, 1. Time up. ABD. Okay. Good. A running process can move to ready state. Yes, that is when you interrupt or preempt. This system called make running process to move to ready state. Ready process moving to running state. Yes, that is also probable. Dispatch. Blocked process can move to running state. No, through ready only any process can go to running state. Blocked process can move to ready state. Yes, that is possible with the resume system call. ABD again should be selected because we want which are true. Okay. Shilpa De, Aarti Seeman, have you got it? Question number 6 on your screen. Match the following process state transitions with its respective system calls. Everybody should be giving the right answer for this. I am expecting 100% right answer for this question. It's a very easy question, guys, but in that 3 hours pressure, we may confuse. So don't think this level of questions will come in the gate. Don't doubt. Will come. Because there is a chance of confusion in that pressure. Hurry. In that hurry, you may commit wrong answer, right? So IITs want to take the advantage of it. That's why. Definitely probable. So give your answer, last 10 seconds. 5, 4, 3, 2, 1. Time up. Option C. Runnable state to running state. Which state is called runnable state? Runnable state means ready state. The other name for runnable state is ready state. So runnable to running, ready to running, dispatch. Waiting to ready, resume. Running to ready, preempt. New to ready, admit. So it is A4, B3, C1, D2, undoubtedly option C. Okay? Good. Question number 7. Consider a processor that uses RR3 scheduling algorithm for scheduling 2 processes arrived at the same time with each 14 millisecond burst time. How many times each process is sent from running state to ready state? Fine, it is part of scheduling, but here I am interested only in this state transitions. That's why I have kept under process states only. Ten seconds left. Time up. It's a very simple one, guys. Let the processes be A and B. A we schedule from 0 to 3, B 3 to 6, A 6 to 9, B 9 to 12, A again 12 to 15, B again 15 to 18, A again 18 to 21, B again 21 to 24, A again 24 to 26, B then 26 to 28. Right? Now, how many times the process is preempted? That is what the point. Running state to ready state. Oh. Sorry. It got erased. A, B, A, B, A, B, A, B, A and B. So 0 to 3, 3 to 6, 6 to 9, 9 to 12, 12 to 15, 15 to 18, 18 to 21, 21 to 24, 24 to 26, 26 to 28. So this is one time A got preempted, second time, third time, fourth time. So 4 times A sent from running state to ready state. Here A is finished at 26. So it is sent from running state to exit state, not to ready state. So we don't count it. Similarly, B, one time, second time, third time, fourth time, sent from running to ready. At this point of time, B also got completed. So it went from running to exit. Hence the answer is 4, not 5. So those who have given 5, please update your scorecard accordingly. No cheating. Be sincere, be honest, because it's learning, right? You are learning it. So you should not be in hurry. You have to be more focused. That is what the new learning for you. You know it, but you are not focused. That's why you have given 5, isn't it? That's what Suraj I am telling. Because of the lack of focus, such mistakes happen. So that is what the new learning for you now. Okay. Let us proceed to next question. Question number 8 on your screen. Consider the below times T1, T2, T3. Pick incorrect relation or relations from below. Okay, update the scorecard means you can update yourself. I will ask, then you can project your score. Quickly read the question and give your answer. 10 seconds left. Three, two, one. Time up. I'll give more 10 seconds. More 10 seconds I'll give. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Now I declare the time up, guys. Suraj has given his answer. Aarti, Simon, okay, C. What about others? Nishu, C. Prasenjit, B, C, D. Okay, no correction. Don't retract the messages. Don't retract. I want incorrect relation. By mistake you have given correct relation means you are wrong. Stick to that. That's a learning for you. Don't retract any messages, any answers. No regrets. We have to do mistakes, then only you can learn. See, T1, time taken by the process to complete, currently in the running state under preemptive scheduling. Okay. That means it may go from running to ready because it is preemptive, ready to running, running to ready, ready to running. In this way, somewhere at some time it may go to exit state. T2, time taken by the process to complete, currently in the ready state with minimal waiting time under non-preemptive scheduling. Means in the ready state there is a minimal waiting time, so it will go from ready to running and it is non-preemptive, so there is no question of coming back to the ready state. So at some stage it will complete and go to exit state. Time taken by T3 be the time taken by process to complete currently in the new state with minimal waiting time under non-preemptive scheduling. So it may go from new to ready. In the ready state there is minimal waiting, ready to running it will go. Then as it is non-preemptive, no preemption, it go to exit state. Exit state. So what would be minimum here? Definitely T2 would be very less because it is already in the ready state. T3 should be loaded into ready state, so it is more, and T1 can be high because it is preemptive. There is a possibility that it can be preempted many times, right? So for ideal conditions, if you take T2 would be smaller than T3 than T1. So this should be the relation. So T2 should be smaller than T3 than T1. Yes, option D is the right answer, but I want incorrect relations, so I should select A, B, C. What happened? What's happening? Wait a minute. So I should select A, B, and C. Clear? Question number 9. Consider the following statements about user level threads and kernel level threads. Which one of the following statement is true? MSQ question. Suraj, no excuses by the system. System don't excuse anyone. So we only have to be careful. Okay, focus on this question. Ten seconds left. Time up. I am giving enough time, guys. So you are unable to give means you are little lagging. You have to speed up the reading. You have to be little fast at reading the question. ABD, A, AD, AB, A, AB, A. Okay, okay, okay. Let's see. Context switch is switch time is longer for kernel level threads than for user level threads. Definitely true. Definitely true. Because user level threads are managed by thread library. So it only update the TCB, thread control block. So, but this kernel level threads should be updated by the kernel. So yes, KLT context switch time is longer. True. And user level threads need hardware support. No, they don't require any hardware support. It's false. Related kernel level threads cannot be scheduled on different processors in a multi-processor system. This is also false. In a multi-processor system, we have multiple processing logic, multiple ALUs. Every ALU can run multiple kernel level threads, multi-threading, possible. It is given cannot be scheduled, so it is false. And blocking one kernel level thread blocks all related threads. This is also false. Blocking one ULT block all the process, but not KLT, because KLTs are managed by kernel itself. Kernel is very much clear, very much aware of how many threads we have, what thread you are blocking. So other threads run in parallel, though the other one thread got blocked, one KLT gets blocked. So the answer should be only A. Only A. Okay. Shruti, I am giving enough time. Competitive time only I am giving. It is not becoming sufficient means you have to read little fast. That is what I would like to remind. Don't feel bad, everybody. If you could not give right answer in the right time, it's not the time to demotivate. It is the time to learn. It is the time to understand, okay, so I have to do this, I have to focus here, I have to be little fast here. Just that is what the purpose of these marathon sessions, right? Because on your own you may not know. Like this, when you attend some sessions, then there is very much probability, very much possibility to commit mistakes, and committing mistakes is very appreciated. because that is the only way to know, to become better ourselves, right? Committing the mistakes is always appreciated. So don't feel bad if you have committed mistakes. Okay? Chalo. Question number 10 on your screen. Read fast and understand and give your answer. It's a MSQ question. Ten seconds left. Time up. Time up. All are with B. Context switch is faster with kernel supported threads. False, undoubtedly. For user level threads, a system call can block entire process. True, because if one thread block, all the process gets blocked. Kernel supported threads can't be scheduled independently. Can't be scheduled. Those who say false, you are correct. They can be scheduled independently. User level threads are not transparent to kernel. This is also false. User level threads are transparent to kernel. Transparent to kernel. Here the meaning of transparency should be understood more carefully. Kernel aware that there are multiple threads, but for kernel every thread looks like same. It is just like all robots, all you just see, just understand, when you go to a shop, you want to purchase, let's say, some product. You are having 10 such products, same like mobile you want to purchase. You have 10 pieces of mobile. So all are same for you, isn't it? At certain stage, even instead of first piece you got third piece also, you don't know the difference, isn't it? Until unless you use, if the sealed box, you wanted to get the first box, but unknowingly you got the fifth box or third box, you don't know the difference. Similarly, here transparency means kernel know that there are multiple threads, but kernel could not identify the difference between them. So it treat all are same. It is treating all are same. So if one gets blocked, kernel can't decide which is that. So it block entire process. Okay, in a simple way I told. In a simple way I told. Okay, just with simple relative example. So definitely user level threads are transparent to kernel. Transparency means this, it know, but it treat all are same. That's why it is unable to distinguish. So we want which statement is or true. So definitely option B is true. Only option B is true. Okay. बात क्लियर है सबको? फटाफट जवाब दो बेटा, आगे चलते। चलिए, क्वेश्चन नंबर 11 on your screen. A thread is usually defined as a lightweight process because an operating system maintains smaller data structures compared with process for a thread. In relation to this, which of the following is true? On per thread basis, OS maintains CPU register state, separate stack, virtual memory state, only scheduling and accounting information. Ten seconds. टाइम अप। अब आपका जवाब दीजिए बेटा। प्लीज गिव योर आंसर। On per thread basis, OS maintains CPU register state. True. It maintains CPU register state on per thread basis. OS maintain a separate stack for every thread. True. OS maintain virtual memory state. False. At process level, virtual memory is maintained. On per thread basis, OS maintain only scheduling and accounting information. False. Because of only, this is false. Because of only, this is false. So I want true statements A, B. बात क्लियर है? आरती, सूरज, साथिया, प्रसेनजीत। नहीं 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 साथिया, आप आंसर नहीं बदल सकते। सो आपका स्कोर कार्ड हॉनेस्टली अपडेट कीजिए अपने आप। जब मैं पूछता हूं तब मेरे को चैट बॉक्स में दीजिए आपका स्कोर, ठीक है? क्वेश्चन नंबर 12। A CPU has two modes, privileged and non-privileged. In order to change the mode bit from 1 to 0, what required? फटाफट जवाब दीजिए, 20 सेकेंड्स लेफ्ट। ये तो प्रीवियस क्वेश्चन है। टेन, 9, 8, 7, 6, 5, 4, 3, 2, 1, टाइम अप। दीपक डी, योगेश सी, श्रुति बी, Okay, Shruti, Deepak, Aarti, Seeman, I think you are attending this class. This is the first class of yours, I believe. First class of yours marathon, right? When the time permits, please go through the last 4 marathons for computer networks and C programming also, guys. Whoever are watching it, if whenever you get the time, please go through the already happened marathons also. You have a separate playlist for it, so no confusion. In that playlist, all marathons are listed. The right answer is a privileged instruction is needed which does not generate an interrupt. See, from 1 to 0, mode bit 1 means user mode or non-privileged mode. Mode bit 0 means kernel mode or supervisory mode or privileged mode. This is what generally the convention. So from user mode to kernel mode, from non-privileged to privileged, privileged instruction is what required. Privileged instruction. When you want to change the settings or some system related files. Here hardware interrupt, software interrupt, that clearly do not assess, because what kind of interrupt, based on that whether it is non-maskable, maskable, such distinction has to be done. So just like such open statement can't decide, but a privileged instruction definitely make the CPU move from non-privileged mode to privileged mode, that is for sure. Even if it generate an interrupt, if it is a maskable interrupt, it may be ignored. Aarti, Seeman, I did not get you. I did not get you better. Which of the following is are shared by all the threads in a process? Program counter, stack, address space, registers. Which is or which are shared by all the threads in a process? Okay, Nishu, logged it. Suraj, yes, they do, provided it is a non-maskable interrupt. Or while servicing the interrupt, definitely mode bit will be changed. Come on, time up. Time up. Address space is what shared by all the threads. Program counter is separate on per thread basis. What's happening? On per thread basis, separate program counter is maintained. On per thread basis, separate stack is maintained. On per thread basis, separate registers are maintained, but shared by all the threads is address space. Okay, everybody. Question number 14. Threads of a process share global variables but not heap, heap but not global variables, neither global variables nor heap, both heap and global variables. Nishu, annotations are not saved. Don't know why. It's a PYQ. Yep. Yep. The right answer is both heap and global variables. That is the right answer. Because global variables that are uninitialized, that gets stored in the stack, initialized global variables stored in the heap, that too for dynamic memory allocation heap is used. Both are shared by the threads. Suraj, initialized global variables. Okay, next question. Which one of the following is or false? ULTs are not scheduled by the kernel. When KLT is blocked, all other threads are blocked. Context switching between KLT is faster than ULT. KLT can't share the code segment. What is your answer? Time up. Nishu, A, B, C, D means all are false. Suraj, B, C, D. Bruce Wayne, B, C, D. Aarti, B, C, D. B, C, D, B, C, D. Meenakshi, A and C. Okay. I want false statement. ULTs are not scheduled by the kernel. True. ULTs are invoked by kernel but scheduled by means their ordering decided by thread library. When a KLT is blocked, all other threads are blocked. This is false. This is applicable for ULT. Context switching between KLT is faster. No. This is false. KLT can't share the code segment. No. Whether it is ULT or KLT, they share the code segment. So I want false statement. So it is B, C, D. Okay. Fine. So guys, our favorite Rakesh Talreja sir is coming up with exclusive general aptitude session for you. If you attend this 15 hours session, of course may not be at a stretch, definitely in the convenient way it will happen coming soon. So please stay tuned for the update, and this combo, very popular combo, this is Rakesh sir and Ankit sir coming up with non-stop maths marathon, through which complete mathematics syllabus you can revise in 2 days with Nothing is Impossible series. That is also coming soon. So if you want to know when, please do subscribe to our BEP channel and press that bell icon so that you will get the notification. So guys, I believe processes means process state diagrams, related system calls, this threads got revised quickly with these 15 questions. अच्छे से रिवाइज हुआ? आपको क्या लग रहा? आपको क्या लग रहा भाई, भाइयों बहनों, बच्चों, बता दो. Aarti, thank you so much, Aarti. Such comments really motivate us. Really motivate us. Thank you. Dear friends, the process states, related system calls, related transitions, threads, this concept got revised with these 15 questions. Yes, no, please share your thoughts. Deepak, yes, thank you. Shilpa, yes. Nishu, yes. Okay, guys, the session is not yet over. Picture अभी बहुत है, बहुत बाकी है. So, are we ready for practicing the very important topic, sure short topic? Definitely you will see a question from this topic, sometimes 2 questions, 3 questions also in some years. Are we ready for practicing CPU scheduling? Chalo. Here is the question number 16. फटाफट जवाब देना. आपका स्पीड एक्यूरेसी दोनों पे ध्यान देना बेटा. आरती, data structures, I think over. Algorithms is over. Computer networks is over. Digital logic is already over. C programming also over. Data structures, I doubt. Acha, data structures will be there from tomorrow morning. Yeah. Aarti, join the Telegram group. There, all schedule is there. CN PDF I will share after this class. CN complete 85 questions PDF I will share. Aarti, there is a playlist, Aarti, in the YouTube. Just go to that playlist. You will get all the marathon sessions. Quick. 20 seconds left. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time up. Time up. Okay. What's your answer? Suraj, 40. Nishu, 40. Okay. Shilpa, 40. Deepak, 30. Fine, guys. Hold your answers. There are 4 processes. Arrival times 0, 2, 1 and 3, and these are the bus times. Now I have to apply SJF. SJF only mentioned, by default it is non-preemptive. Preemptive SJF would be clearly given, or SRTF term will be used. So if I go with the Gantt chart, at 0 I have only one process available, A. As it is non-preemptive, I let it complete. Now the time is 5, other processes have joined. Now I go with the shortest job, that is D. D require 3 units of time. Then B. B require 6 units of time. Then C. 7 units of time. This is what the Gantt chart. Now let X be the waiting time of a process, Y be the turnaround time of a process. So what is Y? That is the turnaround time of process D. No, process B. Okay. So what is turnaround time of process B? Process B arrived at 2, completed at 14. So 14 minus 2, 12. And what is X? Waiting time of process D. D arrived at 3, scheduled at 5. So it is 2. So X is equal to 2, Y is equal to 12. Now 2x plus 3y, 2 into 2 plus 3 into 12, 4 plus 36, 4040. Okay, good. Question number 17. Consider the processes information given below. The average turnaround time under HRRN scheduling is. Give up to 2 decimal places. Give up to 2 decimal places. Quick. 40 seconds left. Last 10 seconds. Focus in the session, everybody. 5, 4, 3, 2, 1. Time up. Time up. Okay. Let's draw the Gantt chart. At 0, we have only one process, D. So we have to schedule. At time is 5 now. Now you have to decide which process among A, B, C to schedule. So at a time 5, I have to calculate the response ratio of A. What is response ratio? Burst time plus response time divided by burst time. A burst time is 4. Response time, it arrived at 2. Now the time is 5. So from 2 to 5 it is waiting for 3 units of time, divided by burst time is 4. 7 by 4, that is 1.75. B, response ratio would be 6 plus 1 to 5 it is waiting, means 4 units of time, divided by 6. 10 by 6 it is 1.33. C, response time, let us see, 2 plus 1 to 5 it is waiting, so 4 divided by 2, 6 by 2, 3. So which is highest response ratio? C is having highest response ratio. So C is scheduled from 5 to 7. Now the time is 7. At time 7, what would be the response ratio of A? A burst time is 4. From 2 to 7 it is waiting, so response time is 5 divided by 4. 9 by 4, 2.25. And what is the response ratio of process B? B burst time is 6. From 1 to 7 it is waiting, so 6 time units. So 12 by 6 it is 2. So A has highest response ratio. So A is scheduled and it is non-preemptive, so you have to let it complete. Now at 11 only one process, that is B, so 11 to 17. So this is what the Gantt chart. Now when we calculate the turnaround times, A arrived at 2, completed at 11, 11 minus 2. For B, arrived at 1, completed at 17, 17 minus 1. C, arrived at 1, completed at 7, 7 minus 1. D, arrived at 0, completed at 5, 5 minus 0. So what is the average? (16 plus 9, 25 plus 5, 36 by 4, 9 time units. 1.66 10 by 6. 6 ones are 6, 6 threes are 8. Okay. Sorry. Yeah. But still C is highest. Yeah. Okay. Thank you. Clear? So you have to be quick as well as accurate. Next question. Question number 18. Consider the processes information given below. If HRRN scheduling is used, which process finish last? $90 seconds left. Last 1 minute. $30 seconds left. $20. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time up. Okay, P3 finish last. Is it so? Let's draw the Gantt chart. At 0, I have P0, P1. No need to calculate response ratio because you will get the same. 3 by 3, 1, 8 by 8, 1. Then we go with the process ID. So P0 we schedule. Now at time 3, let us calculate response ratio of P1. P1 burst time 8, waiting for 3 units of time by 8. So 11 divided by 8. Maybe it is 8 ones are 8. 8 2 8 3s are 24. 8 7s are 56. 8 5s are 40. 1.375. And what is the response ratio of P2? Burst time 2, from 3 to it just arrived. So 2 plus 0 by 2, it is 1. And P3 4 by 4, 1. So P1 response ratio is high. So you will schedule P1 from 3 to 11. Now at time 11, response ratio of P2, 2 plus, from 3 to 11 it is waiting. So 8 divided by 2, 10 by 2, 5. Response ratio of P3, Burst time 4, from 3 to 11 it is waiting, so 4 plus 8 by 4, that is 12 divided by 4, 3. So which has highest response ratio? P2 only has highest response ratio. So we schedule P2 from 11 to 13. So finally only one process left, P3. So 13 to 17. So which finish last? P3 finish last. Good. I think it is clear. Question number 19 on your screen. Guys, keep liking the session, please. Keep liking, keep sharing. Consider the processes information given below. The percentage of time CPU is idle while executing above processes under FCFS scheduling is up to 2 decimal places. You may share. You just need to derive the Gantt chart and find the idle time. Forty seconds left. Twenty seconds left. Nine, 8, 7, 6, 5, 4, 3, 2, 1. Time up. What's your answer? Okay. First come, first serve. So, no complexity. At 0, we have no process available. So, from 0 to 1, CPU is idle. At 1, I have A and B, same arrival time, I go with the process ID. So, A 1, 2, 3, then B 3 to 4. At 4, I have no process. So, from 4 to 5, again CPU is idle. At 5, C joined. So, C is scheduled from 5 to 8. At 8, I have again no process. When another process joined at 10. So, 8 to 10 CPU is idle. At 10, D joined. So, D is scheduled. From 10 to 12, it executed. Again at 12, no process for CPU to execute. So, idle. At 14, E has come and scheduled. So, for this processes information, CPU idle percentage, if you take 1, 2 plus 2, 4 plus 2, 6 cycles, CPU is idle, right? So, 6 out of 15. 40% is the CPU idle time. 40%. Why all have given the wrong answer? What is the difficulty? No. By default, you should start from 0 only. Okay. Question number 20. Consider the processes information given below. If non-preemptive priority scheduling is used with priority calculated as arrival time by burst time, then dash process finish last. PRST. Which process? No, Suraj. From 0 only we have to start. Okay. Focus on this question. Question number 20, please. Guys, priority 0 highest. Wait, let me give. Priority 0 means high priority. In that way you understand. Again, don't say I did not mention. Priority 0 means high priority. Okay. 1 first priority, second priority, like that. Ten seconds left. Time up. I just asked which process finished last. You need not to calculate any TAT or WT, nothing. And it is non-preemptive priority. So it is so simple. So first let me calculate the priority. How? Arrival time by burst time. So 0 divided by 4, 4 divided by 2, 9 divided by 3, 6 divided by 1, 6 divided by 2. So 0 is high priority, 6 is low priority. So straight away you can say yes, finish last. But we have to see the arrival times also. So let us draw the Gantt chart. Okay. At 0 I have P, its priority is S high. So 0 to 4 it execute. At 4 I have only one process Q. So 4 to 6 it execute. At 6 I have two processes S and T. So T has more priority. So T gets executed from 6 to 8. At 8 I have only one process S. So it execute, and then I have R. So the process that finished last is R. Suraj Mishra, Satya. Just by looking the priority, you might have said without calculating completely. Fine, S has low priority, but when high priority process is not available at that time, obviously available process is scheduled. Got it? Deepak, maybe for this question it could be same, but I just want to be very clear so that later no confusion. Maybe if it is a 0 high, 0 low, there could not be any difference. I just want to be complete clear. Question number 21. Before that, now everybody, you can download our free ebook and you can get up to 90% scholarship through our scholarship tests, which we are conducting on a periodic basis. Today also there was a scholarship test at 12 p.m. I think if the link is still alive, I think active, if you people can go through it, or you may guide your juniors or friends for going through that scholarship test, so that up to 90% scholarship on the preparation programs you can get. And we are conducting regular workshops to motivate you guys, to give you tips, tricks. So if you want to get all these updates, please do subscribe to our BEP channel and enable your notifications by pressing the bell icon, and do register for these workshops, scholarship test by the links given in the description box. Okay, thank you. Let's proceed to question number 21. Here is the question number 21, dear friends. Let processes W, X, Y and Z have arrived at same time with CPU requirements so and so. Then the total waiting time of process Z is dash time units if HRRN scheduling is used. Quick, 40 seconds left. Last 20 seconds. 10, 3, 2, 1. Time up. What's your answer? Initially all have arrived at same time. Okay, as nothing is mentioned, we can understand they have arrived at time 0. When all arrived at same time, you will get the same response ratio. Then you go with what? Process ID. So W 0 to 3. Now at a time t is equal to 3, if I calculate X response ratio, 4 plus 3 divided by 4, 7 by 4, 1.75. Y response ratio, 5 plus 3 divided by 5, 8 by 5, 1.6. Z response ratio, 7 plus 3 divided by 7, 10 by 7, 1.42, something like this. X has high response ratio, so X is scheduled after W for 4 time units, means 3 to 7. Now at a time t is equal to 7, I have two processes Y and Z. So Y response ratio, if I calculate, it is 5 plus 7 by 5, 12 by 5, that is 2.4. Z response ratio, when I calculate, it is 7 plus 7 by 7, 14 by 7, 2. So Y has highest response ratio, so we will schedule Y from 7 to 12. Now Z, 12 to 19. So Z arrived at time 0, initiated at 12, no preemption. So the waiting time of process G is 12. Suraj, even if I show it, it would be more clear, no? If they arrive at the same time, it would be in the process order, arrival in the process ID sequence. If I show it, it would be more clear. Okay. Question number 22. Guys, any doubts? Please feel free to ask. Okay. Let's proceed to question number 22. Find out the scheduling sequence for processes A, B, C, D which have arrived at a time 3110 with burst requirement so and so under SJF scheduling. 2 minutes is not required actually. So in 1 minute I'll end the timer. In 1 minute I'll end the timer for this question. Yes. Option A. Okay. Guys, at time 0, I have only process D. So undoubtedly, I go with it. It runs for 2 units of time. So B and C joined. In B and C, B has less burst. So B I schedule. Now A also joined because at 3 it joined. Now in A and C, A is shorter. So 6 to 8. Then C, 8 to 15. So DBAC is the right answer. Next question. Consider the process table given below. Find the sequence of process completion using HRRN scheduling. Guys, this time HRRN scheduling is expected scheduling question. Fifty seconds. Last 30 seconds. Five, 4, 3, 2, 1. Time up. Okay. Try drawing the Gantt chart. Nishu, yes, it is non-preemptive. At a 0, I have A. So I go with A. The time is 3. I have only B available. So I go with B. The time is 9. The time is 9. So at time 9, I calculate the response ratio of C. That is C, burst time 4, response time 5 by 4, 9 divided by 4, D response ratio 5 plus 3 by 5, 8 by 5, E response ratio 2 plus 1 by 2, 3 by 2. So C has highest response ratio. So we schedule C from 9 to 13. At time 13, D response ratio would be 5 plus 7 divided by 5, 12 by 5. E response ratio would be 2 plus 5 divided by 2, 7 by 2. So this is 3.5, this is 2.4. So E has highest response ratio. So we schedule E from 13 to 15, then D. So A, B, C, E, D is the completion sequence. Option B is the right answer. Okay. Okay, everyone. So may I know your score? What is your score? What is your score, dear friends? Out of 23, how many questions you made correct within the time? See, 2 hours is over, only 23 questions. In the GATE exam, 3 hours, 65 questions. That means you can understand I am giving more than enough time. Suraj, 17, Ashwati 14, Nishu 15, Prasenjit 16. Nishu, question can I have little more proper, little more clear? Aryan, okay. Others, what about others? Fine, guys. Stay tuned. We have more 22 questions waiting for us. So let's have a break. More 22 questions are there. Okay. Let's have a break, guys. Welcome back. Am I visible and audible for everybody? Could you please confirm? Could you please confirm, everybody? Am I visible and audible? Okay. Deepak, see, synchronization questions are definitely time-taking questions. Generally, they take 3.5 minutes. Some questions even demand 5 minutes also. Easy questions will be there definitely. 10-15 questions will be there. Very easy. Means less than 1 minute time taking questions or direct questions. Very simple questions. In such questions, you have to save the time, accumulate all such time, all such questions time. That you have to spend in the synchronization kind of questions. Okay? Okay guys, let's proceed to question number 24. Here is the question. An operating system uses SRTF policy. Consider arrival times and execution times given. What is the total waiting time for process P2? Yeah, for process B. For process B. Suraj, for process B. Last 5 seconds. Time up. What is your answer? Option B. Okay. Let's see. We follow SRTF policy. SRTF policy. So, at a time 0, we have only process A available that we schedule. Until 15, there is no other process. So, until 15, if I schedule, A remaining time would be 5. At 15, B join. B remaining time 25. So, A is still shorter. So, we schedule A only. Now, at time 20, we have only process B. Till 30, there is no other process. So, at 30, till 30, from 20 to 30 we have executed B. So the remaining time of B would be 15. Now at 30 C joined, C remaining time is 10, which is shorter than B. So preempt B and schedule C. Now C gets finished from 30 to 40. At 40 D still did not join, so we go with B. At 45 B will have more 10 remaining time. At 45 D joined, but still process B is having less remaining time, so we continue with B only. And finally D. So this is the Gantt chart. Now I want waiting time for process B. B waiting time would be what? B turnaround time, if I calculate, B finished at 55, arrived at 15, so turnaround time is 40, and waiting time is turnaround time minus burst time. So 40 minus 25, that is 15. Okay, so 15 is the right answer. Question number 25. Consider 4 processes A, B, C, D with arrival times and burst. Average turnaround time under RR3 scheduling. Aryan, yes Aryan. New process is given priority. Means for which algorithm? For SRTF? Yes. No. Same process. No, same process. Because that is already in the running state. Only when shorter remaining time come, then only we preempt. It is clearly telling shortest remaining time. So if the same remaining time, it is not preempted. Twenty seconds left. Ten, 5, 4, 3, 2, 1. Time up. What is your answer? RR3. At 0, we have process D available. So we schedule from 0 to 3. Right? Now please understand, for round robin, it is good to maintain this log. At arrival time, 0, I have process D scheduled. Now at time 3, at time 1, A joined, at time 3, B joined and D preempted. So B came from new state, D came from running state. We give new process priority. So we schedule A. Now D has more 3 remaining time. A we schedule, A has more 5 remaining time. Then B we schedule, B has more 1 remaining time. Then D we schedule, D got finished. So go to exit state. So at time 6, A joined the ready state back, but at 5, C has come. At 9, B joined the ready state. So in this sequence, we give priority for C. So C we schedule from 12 to 15, C got finished. Now A, 15 to 18. So A still has 2 remaining time. Now B, 18 to 19. Now only A is left. B got finished. A is left from 19 to 21. This is the Gantt chart. Right? Now I want average turnaround time. So turnaround time for A would be 21 minus 1. B would be 19 minus 3. C would be 15 minus 5. And D would be 12 minus 0. So this is 20, 16, 10, 12. So average would be 36 plus 10, 46 plus 12, 58 divided by 4, 14.5. Option D is the right answer. If D would have burst time as 9, then after CD, after Nishu, no Nishu. Today scheduling processes threads, disk scheduling. We have more 10 questions of CPU scheduling. So today major part we are solving CPU scheduling because it deserves. Because definitely we get question in the GATE exam from CPU scheduling topic, and we have 9 different scheduling algorithms to practice. So altogether 25 questions I have kept only from CPU scheduling. Okay. So after CPU scheduling questions, we have disk scheduling questions. With that, today marathon would be over. Tomorrow we practice synchronization, paging, deadlocks, and file systems. Of course, system call questions. Okay. What if D has burst time as 9? What to do with the burst time as 9? If D has burst time as 9, D would have got at 12. So after B, D would have been scheduled. Because A would be preempted at 18, after B, D would have been scheduled. Okay. Question number 26. Consider the processes information given below. The total number of process preemptions under SRTF scheduling is. Last 1 minute. Twenty seconds left. Time up. What's your answer? At time 0, we have process C, process E. Burst time, when you take remaining times, E has less remaining time. So E I am scheduling. At time 1, A has joined. By that time E finished 1 unit of time. A has less burst than E. So A is scheduled. At time 2, B joined with 3 burst time. By that time A has finished 1 unit of burst. So A remaining time is 4, B remaining time 3. So B is scheduled. At 4, B will have 1 unit of time. D also has 1. As it is not shorter, B only finish its execution. So B got completed. Now we have A, C, D, E. D has less burst, so D is scheduled, finished. Then A has less remaining time, then E has less remaining time, then C has next. So this is the Gantt chart. Now I want process preemptions. Here E is preempted 1 time. Here A got preempted 1 time. Here B finished, terminated, not preempted. Here D terminated, not preempted, A terminated, not preempted, E terminated, C terminated. So total number of process preemptions 2. Okay. Question number 27. Consider the processes information given below. The process completes at time t equal to 8 is P1, P2, P3, P4. Which process finish at time t equal to 8? Quickly solve, everybody. One minute left. One is low, 3 is high. Sorry. Wait. 1 means high, 3 means low. Okay. Quick. Time up. You need not to derive complete Gantt chart. Just till time 8 you have to do. Which process? At 0, only P1, P4 are available with the same priority. Then we go with process ID. Okay. Now, do we take non-preemptive priority or preemptive priority? Let us do with non-preemptive priority once. It is not given in the question, but first let us try non-preemptive priority. Then P1 would finish at time 8. Right? According to non-preemptive priority, P1 finish at time 8. If I take preemptive priority, at a time 0, P1 we schedule. At a time 1, P2 joined with more priority. So, at a time 2, P5 joined, that is the highest priority. So, P5 complete. Now, we have 5 processes. P2 arrived at time 2 back after preemption. P3 also arrived at time 2. So we go with P3, isn't it? P2 did 1 unit of time. Now P3 has more priority. So P3 we do from 6 to 11. So at process 8, no process is completing. At time 8, no process is completing in this preemptive priority. So straight away you can go with option A. Okay. Maybe that is the reason why it is not mentioned preemptive or non-preemptive. No, at time 2, P2 came from running state to ready state. At the same time, P3 came from new state to ready state. At the same time, both have the same priority, same arrival time. So we give new process priority. Okay. Is that clear? When the arrival time is same, then we go with this. Like that you can't generalize Aryan. In the FCFS, arrival time is same, we go with the process ID. In the SRTF, arrival time is same remaining time. Then we don't preempt the running process. We continue the running process. So we can't generalize like that. In round robin, we go with the new process because their burst time is not at all considered. Here, new process because the same priority. Okay. Deepak, after CPU entering time will be after 6. What? Deepak, clearly I have explained. At a time 2, P2 got preempted. At the same time, P3 got admitted. So always new process is what scheduled in such case. P2 left CPU 4 seconds before. 4 seconds before. What? Where it is mentioned? P2 left CPU बोल के. P2 preempted at 2 only, no? Because of P5, P2 preempted at 2 only. Deepak. Question number 28. Consider the processes information given below. The total number of context switches under RR2 scheduling is. Quick. Forty seconds left. Okay, Suraj says 11. Okay. Ten seconds more. Time up. Let's see. All processes arrival time is the same. So we go with the process ID and RR2. So A 0 to 2, B 2 to 4, C 4 to 6, D 6 to 8, E 8 to 10. These are the remaining times. Now again A 10 to 12, B 12 to 13, D 13 to 15, E 15 to 17. Now A 17 to 19 and D 19 to 20. Now context switches. From some other process to A it is switching 1, here 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. From D to some other process CPU switch. So total context switches are 12. Okay. Question number 29. Consider the processes information given below. Let X be the completion time of process P if non-preemptive SJF is used. Y be that of same process under preemptive SJF. Then which relation holds good? Last 40 seconds. Okay. Aryan says C. Suraj says C. Quick, guys. Time is running out. 5, 4, 3, 2, 1. Time up. Let us solve preemptive SJF, non-preemptive SJF. First, non-preemptive SJF, let us consider. At time 0, I have only process P. So P is scheduled. That's it. So completion time of P is X in non-preemptive. Now, preemptive SJF, if I see, no need to do other process, just bound to the question, okay? Preemptive SJF. At time 0, P only available, scheduled. At a time 1, I have got Q and T. Q has less remaining time than P. So Q is scheduled. Now at a 3, R joined, R has less remaining time. R is scheduled. Now time is 5, S joined. P arrival time is 1, S arrival time is 5. So P arrived before S. When arrival time is same, we would have considered S. But arrival time is different. P arrived before S. So we schedule P. So completion time of P under preemptive SJF is Y. So what we can take, Y is equal to 2X. Because Y is 8, X is 4. Right? So Y equal to 2X. Good. Next question, question number 30. Consider MLFQ algorithm for a process initiated by RR2 in Q1. Let us suppose that when a process switch from one queue to another, its time slice doubles and the total CPU requirement is 40 units. Let I be the remaining time of a process in Q2 and J be in Q4. Then Prasenjit, Deepak Prasad, after the class, ping me personally in the Telegram group. Okay? Aryan Kaurav, Ashwati, you also. Last 20 seconds left. Kalyan, if you are there, you also please do ping me. If you are watching it live, please ping me in the Telegram group personally. 5 seconds left. Time up. It's a multi-level feedback queue algorithm. Under RR2 we have to start with the Q1. So Q remaining time, if we do in Q1, we are following RR2. So the remaining time would be 40 minus 2, 38. When the process switch from Q1 to Q2, time slice doubles. So it becomes RR4. So the remaining time would be 34. In Q3, it even double. So 34 minus 4, 34 minus 8, 26. It even double in Q4. 26 minus 16, 10. It even doubles in Q5. So there it finish. Okay. Let I be the remaining time of a process in Q2. So I is 34. J be in Q4. So J is 10. So I is 34, J is 10. So we can say I is equal to 3J plus 4. Got it? Question number 31. Consider a system executing 8 processes P0 to P7 with burst times 1, 2, 4, 5, 6, 3, 4 and 7 time units with arrival times so and so. Consider system is using MLQ scheduling with 3 queues such that P0, P3, P7 in Q0, P2, P6 in Q1, remaining in Q2. Q0 use FCFS, Q1 use RR3, Q2 use SJF scheduling. Priority of QC is Q0 less than Q2 less than Q1. Then process ID of last process that finish its execution is. It's a little lengthy question, guys. Fine, I give more than 2 minutes, but solve carefully. Okay, let us solve. We have 8 processes, P0, P3, P7 in Q0. Q number, process ID, P0, P1, P2, P3, P4, P5, P6, P7. P0, P3 and P7 in Q0, right? P2, P6 in Q1, P2, P6 in Q1, remaining in Q2. Burst times 1, 2, 4, 5, 6, 3, 4, 7. 1, 2, 4, 5, 6, 3, 4, 7. These are the burst times. And arrival times 0, 0, 3, 1, 2, 5, 7, 2. 0, 0, 3, 1, 2, 5, 7, 2. And it is given Q0 has less priority than Q2 than Q1. Q0 has less priority than Q2 than Q1. So Q1 has more priority than all the other processes. And it is also given Q0 use FCFS, Q1 use RR3, Q2 use SJF. Q0 uses FCFS, Q1 RR3, Q2 SJF. Right? Now, at time 0, at time 0, what processes we have? We have at time 0 P0, P1. P0 belongs to Q0, P1 belongs to Q2. Q2 has more priority. So, we schedule P1. P1 require 2 units of time. But at time 1, P3 came, but it still belongs to less priority queue, so no worries. So P1 is scheduled from 0 to 2. Now the time is 2. We have, so P1 got completed. Now the time is 2. We have P0, P3, P4, P7. Now P0 belongs to Q0, P3, Q0, P4, Q2, P7, Q0. Q2 has more priority, so we schedule P4. P4 requires 6 units of burst. But at time 3 only, we got P2 that belongs to Q1, which has high priority. So P4 executed only till 1 unit of time. Here you may get a doubt. Sir, SJF is non-preemptive. How you can preempt? SJF is non-preemptive, no denied, not denied. Here SJF is not, the process is not getting preempted because of another short process. Here the Q has high priority than any other parameter. So it dominate. Okay. So P4 we have scheduled. Now P4 preempted. Now what we have scheduled? P2. P2 follow RR3. So P2 scheduled from 0 to 3 to 6. But another process that belongs to Q1 come at 7. So at 6 no other process belongs to Q1, only P2. So this only scheduled again, because high priority Q. High priority Q. So P2 got completed. Okay. Now at time 7 we have P6 high priority. So P6 will finish. That is the high priority, because at 11 also we don't have any other process. So P6 finished. Now we have the other processes. Among them Q2 has more priority. So Q2 processes we have to finish. Q2 arrival time of P4 is 3. P5 is 5. So P4 we schedule. Oh, wait. Q2 follow SJF scheduling, right? SJF scheduling. So in P4 and P5, which is shorter? P5 is shorter. So P5 we schedule from 11 to 14. Then P4 we schedule from 14 to 19. So P4 got finished, P5 got finished. Now we have only FCFS algorithm based processes. Arrival time. P0 arrived at 0. P3 at 1, P7 at 2. So clear, we go with that sequence. P0 from 19 to 20, then P3 from 20 to 21, 20 to 25, then P7 25 to 32. So which process finished last? P7 finished last. Hence the answer is P7. Means the process ID is 7. Guys, this is little complex. Those who did not get complete clarity, I request them to listen multiple times so that you will understand. Okay. Let's proceed to next question. Question number 32. Yeah. It's a previous year model, question model, but values are changed. Values are changed. It's a same model, similar model of previous year question. So you have to solve it. Solve it, guys. Harsh, It is not the same question. Complete data is same, but values got modified. So solve it. Read the question properly. I want when process C complete its second IO operation. Thirty seconds left. At least I start explaining after the time. I know it takes little more time. So you can keep me on mute and you can solve yourself while I am explaining. Okay. Fine. Let me time up. We have these processes given. They follow round robin with 30 milliseconds burst with arrival time 0, 5 and 10. Okay. So at a time 0, A will start 0 to 30. By that time B and C also joined. So B, then C, then A, then B, then C, then A. Now A enter into IO burst till 410. So A IO starts 200 milliseconds. So till 410 A is in IO. Now B 240, C 270, B 280. B burst is over 100 milliseconds. Now B enter into IO for 300 milliseconds. Now we have only C 310. Now C enter into IO from 310. From 310 C enter into IO for 150 milliseconds. That means C will resume at 460, B resume at 580, A resume at 410. That means from 310 to 410, CPU idle. For 100 milliseconds, CPU idle. Now, at 410, only process A resumed. Its second iteration started. RR30 we have to follow. At 440, do we have any available process? No. So at 440 also A is scheduled. 30 milliseconds you will give maximum. Now C came at 460. So now you will give C a chance. Still B is not available. So between A and C only this will go on. A finished its second iteration, CPU burst. Now A enter into IO for 200 milliseconds. Means till 730. Now I have only C at 530 till 580. I have no other process. 530 to 560, 560 to 590, sorry, till 590. Now at 590 means at 580 only B is resumed. So by that time here 30, here 60, 90 over, so C still has 30 milliseconds. Now B will be given a chance, 590 to 620. Now C would finish its a CPU burst at 650. C enter into IO for 150 milliseconds. So CIO would be for 150 milliseconds. That means AIO would be from 530 to 730. CIO would be from 650 to 800. So when process C finish its second iteration at 800 milliseconds, process C finish its second iteration means both CPU burst and IO burst at 800 millisecond. So the answer for this question would be 800. Okay? Those who did not understand this, please rewatch it, re-listen to it. Okay, a couple of times, definitely you will understand. Chalo, let's proceed to next question. Again, this is previous GATE question, but I have changed it to second instance. The previous GATE question was first instance of T3 complete when. I want second instance of T3 complete when. Solve it. Thirty seconds left. Ten seconds left. Time up. What is your answer? Given there are three tasks, T1, T2, T3, their burst requirement is 124 milliseconds. And priority is inverse of its period. So priority is 1/3 1 by 7, 1 by 20. That means whose period is more, their priority is less. So 1 by 3 is given high priority, 1 by 20 low priority. And here the arrival times plays important role. T1 arrive periodically at interval of 3, means at 0 it is available, again this task occur at 3, again at 6, again at 9, again at 12, again at 15, again at 18, again at 21, again at 24, like this. Similarly, T2 period is 7. So at 0 it is there, it occur again at 7, again at 14, again at 21, again at 28, again at 35, and so on. Similarly, T3 period is 20. Initially it is available. See, all tasks initially arrive at the beginning of first millisecond. First millisecond means 0. Then it again occur at 20, then at 40, then at 60, then at 80, so on. Like this. So this is what we have to understand majorly. Harsh Modi, no, I want the second instance. It's not the same question. I have changed first instance to second instance. I want second instance. So let us proceed with the Gantt chart. Okay. At 0, T1 start. What are the burst times? 1, 2, 4. Remember. So T1 execute. Then T2 at time 3, it execute till time 3. T1 periodically occur at time 3 again, which has more priority. Okay, so T1 arrival time is 0, 3, 6, 9, 12, 15, 18, like this. T2 T3 arrival times are like this. So at 0 it arrived, again it arrived at 3, which has more priority. So T1 we schedule, burst time is 1. Now at time 4 we have only T3 available. So T3 is scheduled till 6. So what is the burst time? 1, 2, 4. 1, 2, 4. This is the burst time. Now at 6 again T1 occur. So T1 is scheduled. At 7 T2 occurred. T2 is scheduled. At 9 T1 occurred again. T1 is scheduled. Now at time 10 I have no process, only T3. So T3 finished its first burst. T3 finished its first burst at time 12. First instance at time 12. But I don't want this. I want second instance. Second instance. Okay. So at a time 12, I got a T1 again. Now time is 13. So 13 to 14, CPU is idle because no process. T1 come again at 15, T2 come at T2 come at 14. So at 14 I have T2. T2 is scheduled, but at 15 I got T1, so T2 gets preempted. T1 execute, then T2. Okay. Now at 17 I have no process. So 17 to 18, again the CPU is idle. Now at 18, T1 available. Now 19 to 21, CPU is idle again. So in this process we have to do, guys. It's not simple question. Maybe in the GATE exam you may not get this complex, but it's better if we solve at this complexity, right? So at 21, T1 is scheduled again, then T2, then T1, then see, I am writing the arrival times again: 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60, 63, 66, like this. These 35, 42, 49, 56, 63, 70. Okay. Now at 25, I have no process. So 25 to 27, CPU is idle again. Now at 27, T1 is scheduled. At 28, T2 came. At 30, T1 came. Again 31 to 33, CPU is idle. At 33, again I got T1. Right? At 34, no process is available. At 35, I got T2. But T2 interrupted at 35 to 36 because high priority process T1 came. At 37, it is resumed. Now 38 to 39, again process is idle. Now T1 is scheduled. Now T2 is available. T3 is available. So T3 execute from 40 to 42. At 42, T1 available, T2 available. So T1 scheduled from 42 to 43. T2 is scheduled from 43 to 45. Now T1 again scheduled from 45 to 46. Now I have no other process, so I will execute T3. So at 48, T3 second instance will be completed. Hence the answer is 48. Okay. Chalo, let's proceed to next question without any delay. Consider the following 4 processes with arrival times and their length of CPU burst given. These processes run on a single processor using preemptive SRTF policy. If the average waiting time is 1 millisecond, the value of Z is. What is the value of Z if the average waiting time is 1 millisecond? SRTF policy, guys, I am also doing it, keeping the time into consideration. You can keep me on mute if you are solving on your own. At time 0, I have only P1 available. At 1, P2 came with rest remaining time. At time 2, P1 gets scheduled. Now at time 4, P3, P4 both are available. One way is, if G is less than 3, I would have scheduled P4 from 4 to 4 plus G, then P3, 4 plus G to 7 plus G. The other possibility is, G may be greater than 3. At 0, P1, then P2, then P1. Now G may be greater than 3, then P3 I will schedule from 4 to 7, then P4, 7 to 7 plus G. Here it is given the average waiting time is 1 millisecond. So here if I calculate the average waiting time, what would be the waiting time of P1? 0, not 0, 1, sorry, because it got preempted. P2 waiting time is 0, P3 waiting time is 1, P4 waiting time is 3 by 4. So this is 5 by 4, 1.25. But given average waiting time is 1. So G greater than 3 assumption is wrong. Incorrect. Let's proceed here. Here what is the average waiting time? Average waiting time. P1 waiting time is 1, P2 0, P3 waiting time 4 plus G minus 3, 1 plus G. P4 waiting time 0 divided by 4. So it is given 2 plus G divided by 4 is equal to 1. 2 plus G is equal to 4. That means G is equal to 2. So the answer for this question is what? 2. Okay. Let's proceed to next question. Last question of scheduling, guys. It is the last question from CPU scheduling. We move on to disk scheduling after this. We wish to schedule 3 processes P1, P2, P3 on a uniprocessor system. The priorities, CPU, time requirements, arrival times, all are given. What are the turnaround times of P2 using preemptive, non-preemptive scheduling respectively? In preemptive, a late arriving high priority process can preempt currently running process with low priority. That means preemptive priority, non-preemptive priority. This is what we have to do. I want turnaround times, P2 turnaround time, and priority given 10 is highest, 8 is lowest. Solve it quickly. Thirty seconds left. Ten, Time up. First, if we go with non-preemptive priority, the Gantt chart, at 0 we have P3, then P1, then P2. If I go with preemptive priority, at 0 only P3 was available. At 3 I have got more high priority process, that is P2. At 5 even more high priority process P1. So P1 gets scheduled from 5 to 25. Then P2 25 to 33. Then P3 35 to 40, 33 to 45. Now P2 turnaround time here would be 45 minus 3, 45 minus 3, 42. Here P2 turnaround time 33 minus 3, 30. So in preemptive, non-preemptive order we have preemptive 30, non-preemptive 42. So 30, 42, option C is the right answer. Yes, correct, Aryan. You are correct. Okay. So guys, total 25 questions you have solved from this CPU scheduling exclusively. Definitely CPU scheduling concept should be very confident. Now you are with these 25 questions. Got revised all scheduling policies, all different types of questions with these 25 questions. All models are covered, I believe. Now I think you are feeling confident. You understood where you are weak at, right? Good. Let's proceed to next topic, disk scheduling. Okay. Fine. Guys, let us solve 5 questions from this disk scheduling and conclude the session. 40 questions let us make it in today's part 1 marathon. We will continue in part 2. Okay. So here is the first question. Consider the following disk specifications. The number of times head change its direction. How many times head change its direction? Quick. Last 20 seconds. Five, 4, 3, 2, 1. Time up. Chalo. This is the surface. Let us mark the cylinder numbers. Let us mark the cylinder numbers. 0 to 99. Now first 9, then 12, then 25, then 32, 41, 47, 50, 63. Now current head position at 50. Okay, so 50 to 47 is near, 47 to 63 or 41, 41 is near, 41 to 32, 32 to 25, then 25 to 12, 12 to 9, 9 to 63. So how many times head change its direction? Only one time. The answer is 1. Ashwani, just one time. Okay. Question number 37. The total seek time we want. If for every 20 milliseconds, for every 50 cylinders, 20 milliseconds is the seek time, what is the total seek time for servicing the above request? After 1 minute, I also start solving along with you. You can keep me on mute if you would like to solve on your own. I will give 1 minute time. The rest 1 minute, let us solve parallelly. Okay. Let us mark the cylinder numbers. Current head position 125. Cylinder numbers, if we mark 10, 20, 30, 45, 80, 120, 125, 140. That's it. Now FCFS we have to go with. So 125 to 20, 20 to 30, 30 to 45, 45 to 80, 80 to 120, 120 to 10, 10 to 140. So the total head movement is equal to 125 to 20, 105 plus 20 to 120, 100 plus 120 to 10, 110 plus 10 to 140, 130. So this would be 445, right? 445 is the head movement. For 50 cylinders, 20 milliseconds is the seek time. For 445 cylinders, what? 445 by 50 into 20. This is 890 divided by 5. 5 ones are 5 sevens are 35, 5 eights are 40. So 178 milliseconds. Yes, Suraj, you are correct. Very good. 178 milliseconds is the total seek time. Clear? Are we clear, guys? Okay. Let's proceed to next question. Question number 38. What is the total head movement if we apply scan scheduling algorithm where the head is moving towards largest cylinder? Do it quickly. All right. I am also doing. Five, 16, 35, 42, 82, 96. Scan towards largest cylinder. Now the total head movement 42, 99, 59 plus 99 to 5, 94. This is 153. 153. Ashwati, 153, not 155. Check it once. Deepak Prasad. Yeah. Next. The sector in a disk is identified with its address represented by triple CHS. Which of the following does represent this triple? It's a multiple select question. CHS, what this CHS can represent? Yeah, Deepak, Suraj, please be careful, okay? Last 5 seconds. 4, 3, 2, 1. Time up. What's your answer? C, cylinder number. H, surface number. S, sector number. Correct. Cylinder number, track number are same. Surface number, sector number. Correct. Cylinder number, head number, sector number. Yes. Track number, head number, surface number. No. So, A, B, C. You have to select what? A, B, C. Last question of the day. Consider the following disk specifications. Total number of cylinders, request sequence, all are given. Scheduling algorithm C-scan, scan. Let X be the number of head movements for C-scan and Y be for scan. then x minus y. Okay. Total we have 100 cylinders, current head position 50. Zero to 99, 15, 25, 35, 45, current head position 50, 55 and 85. So if I follow first scan scheduling, and what to take towards largest cylinder, you please take towards largest cylinder. So 50 to 99, 99 to 15, and if I go with the C scan, 50 to 99, 99 to 0, 0 to 45, right? So here the head movement is 44 plus 84, 128. Here, oh wait, 52, 99, 49, 49 plus 84, that is 133, and here 49 plus 99 plus 45, this would be 49, 50, 90, 148, 153, 193, isn't it? (193). So X is C scan, Y B scan. So it is X, this is Y. So X minus Y would be 193 minus 133, 60. Yes, good, good. Suraj, Aryan, very good. Okay. Yes, so that's all for today's marathon. Out of 40, may I know your score, everybody? Everybody, what's your score out of 40? Out of 40. Forty questions only we solved, no? Fine. This is my Telegram group link. If you have not joined yet, please do join. CS_by_Satyanarayana. If you type in the Telegram, you will get. Join for any doubts, or if you want to connect with me, or to download this PDFs and to connect with your friends. Okay. 23, 29, 27. Fine. Please identify your mistakes. Don't repeat them. Learn from the mistakes. Okay. Let us meet in part 2 marathon tomorrow. And guys, please do like the session, share and subscribe to our BYJU'S Exam Prep channel. Thank you so much for joining the session. I hope you liked it. I hope you have learned so many things, so many concepts, or you revised all this CPU scheduling, disk scheduling, processes and threads concept, whatever we have practiced today. It was helpful to you. So keep learning, keep growing, guys. Okay. Aryan, you can get the PDF from the Telegram group. Chalo, good night everyone. Good night everyone. See you tomorrow sharp at 4 p.m. in part 2 marathon of operating systems. Thank you. Have a great time. Take care. Bye-bye.